Hello everyone. So in this video, we will be learning LDR sensors in IoT. Today, I'm going to present a presentation on LDR in IoT, their working, their application, and their future scope as well. LDR is one of the most powerful sensing technologies enabling modern intelligent systems like autonomous vehicles, robotics, and smart cities. Let's explore how it works and why it's so important. What is LDR? First of all, LDR stands for Light Detection and Ranging. It is a remote sensing technology that uses laser light to measure distances very accurately. The basic idea is very simple. A laser pulse is sent towards an object. A sensor measures how long, a sensor measures how long like the a sensor is used to measure how remotely that laser light measure distance very accurately. The basic idea is simple. A laser light pulse is sent towards an object. The sensor measures how long it takes to return. That time is used to calculate a distance. This method is called time of flight that we have studied in physics as well. It allows LDR to create precise 3D maps of the environment. So let's dive into the how LDR works. So let's understand the working step by step. First of all, the sensor emits a laser pulse. The pulse hits an object. The reflected signal returns to the sensor. Then the system computes the distance. The formula used is distance equals to speed of light multiplied by time divided by 2. We divide by 2 because the light travels to the object and back, to and fro. This process, uh, this process happens thousands to millions of times per second, creating a detailed map, which helps LDR to have a very specific information about the particular object he has been target, to calculate the particular distance. So this is how the in the particular core of the LDR, this is how the LDR works in that core. Moving on, we have LDR sensor specification. Here are three main types of LDR. First of all is mechanical LDR, which is used for rotating parts, well established but bulky it is. And we have solid state LDR, no moving parts there are, but it's more compact and it is more durable. And last of all, we have FMCW LDR, advanced type with a very high accuracy and velocity detection, which is also very useful LDR. Like all these types of LDR have their different uses. Each type is differed by accuracy, scan rate, and resolution. So you can see the the chart has been given here where you can uh, like compare the feature of each and every type of LDR. And so today's solid state and FMCW LDR are gaining popularity due to their compact size and better performance. So signal performing and point cloud data. LDR doesn't just measure distance, it generates massive data as well. Here's how raw data becomes useful. First, raw data becomes useful because first raw signals are captured, then distance is calculated, points are combined into a 3D structure called a point cloud, noise is filtered out, data is compressed for storage. This process allows system to understand their surrounding in real time with very efficiency. Next we have is environmental challenges for LDR. Although LDR is very accurate, it faces real-time challenges as well, like rain, fog, and snow scatter the laser signals it as it collides with the particles in the environment present. Bright sunlight can interfere with detection as well. Reflective surfaces like glass can cause errors. Dark surfaces absorb light, reducing accuracy. Multi-patch reflections can create false readings. To overcome these systems, we are using advanced algorithm and sometimes multiple sensors as well. LDR versus other sensors. First of all, LDR is very high accuracy and 3D mapping. Here you can see that everything has been mentioned about how it has been different from other sensors as well. Here you can see the radar. It works well in all weathers, but lower resolution it offers. Ultrasonic, it is very cheap, but short range it is. Cameras do provide visuals, but struggle in low light. Thermal, they detect heat, but not the particular shape. Because no sensor is perfect, modern systems use sensor fusion, combining multiple sensors for a better results. Next, we have applications on IoT. LDR is used in many IoT applications like autonomous vehicles for navigation, obstacle detection, smart cities for traffic monitoring, drones for mapping and surveying. robotics for movement and collision. These are used in application of in the IoT, like robotics, industrial automation, indoor navigation, and retail. Next, we have advanced application. Like these, like the previous one were one of the basic. Now we dive into the advanced application. Like for the SLAM and the 3D reconstruction, we use SLAM is basically for real-time mapping and relocation, localization, gesture recognition for touchless interfaces, geological interfaces surveys, medical imaging like eye diagnostics like these all come in the advanced application. Now we have advantages and limitation. First of all, advantages we have, they are very high accuracy for distance and mapping and works very well in low light as well and darkness as well. It provides detailed 3D data. Some limitations we also have, like expensive compared to other similar sensors. The performance drops in bad weather, the higher power consumption. It's powerful but must be used carefully depending on the application. That's about LDR. And let's talk about some integration consideration. While implementing LDR in IoT systems, we must consider hardware integration, real-time processing, power management, and other features like regular calibration, edge versus cloud processing decisions, because these are very important. Now let's move on to the market trends. Moving on to market trends, we have expected to reach around 5.5 billion by 2028, growth driven by the autonomous vehicles and robotics. Yet costs are decreasing, making it more accessible. New companies are entering into innovative ideas. Now let's discuss the components of LDR. In the components of LDR, we have laser emitter, sends light pulses, photo detector receives reflected signals, scanner and optics control the direction, GPS and IMU, which provide position and orientation for mapping, which is very important. All these components work together to create accurate spatial data. And future of LDR, we all know. And as AI integration can be done, cost reduction can be done, compact sensors can be also included. So, so to conclude our presentation, we have seen LDR is transforming how machines understand the world. Its ability to generate precise 3D data and makes it essential for automation, smart infrastructure, and future technologies. As it becomes more affordable and advanced, LDR will play a crucial and central role in the next generation of IoT systems. Thank you for the opportunity.